Hi guys, welcome back to the vlog.
Okay. 10.5. We are going to talk about similar solids. When something is similar, what does that mean they create? Done similar, like triangles, what does that mean they are? If something's similar, they're the same shape, they have the same what? When we talk about similar triangles, the triangles had something that were congruent and something that were just similar. What was that? The angles are congruent, the sides are similar, and how do we show that? In what type of form?
Proportion?
A proportion. So when we're dealing with similar solids, we're also going to have proportions. Okay? Proportions. Just like two-dimensional figures, solids can be congruent. All their dimensions will be identical. However, just like two-dimensional objects, 3D objects can also just be similar. Okay? Where they are proportional. Definition of similar solids. Similar solids have congruent angles and their linear measures are the same ratios, okay? So that means my angles are still all the same when I have similar 3D objects. It means my proportions come out to be the same. So this is a 9, 9, 9, 3, 3, 3, right? So this side length right here of 9 and this side length of 3 is a 9:3 ratio, which means it's a 3-to-1 ratio, right? Because you move it down. This side is also 3-to-1. This height is also 3-to-1. Because all of those three are the same, they're similar figures. So the length, the width, and the height all have to have the same proportion. Does that make sense? Okay. The ratio of the bases, look, 9, the ratio of the bases, 9, 9, 9 plus 9 plus 9 plus 9 is 36, correct? The perimeter, okay? 3 plus 3 plus 3 plus 3 is 12. The ratio of the bases is 36 to 12, which scales down to 9 to 3, which scales down to 3 to 1. So the ratio of the perimeter is also the same as the ratio of the side lengths. So if the perimeter ratio is the same as the side length ratio, you have similar figures. What do you think the area ratios are going to compare? How are they going to compare?
The same?
Not the same. Think about area. What do you do when you have area? What unit of measure do you put at the end? Squared. So what do you think the area ratios are going to look like compared to the perimeter ratios? They're going to be squared. What would the volume ratios look like compared to the perimeter ratios? Cubed. Okay? Does that make sense? Okay? Okay. Congruent solids. Two solids are congruent if they have the following characteristics. I'm just beating this into your head. Corresponding angles are congruent. Corresponding edges are congruent. Corresponding faces are congruent. And volumes are equal. Remember we talked about this yesterday. If my cross section is equal and my height is equal, my volume is equal, okay? So here's the proportions here. A height 1 over height 2 equals the slant height over slant height 2, which equals 1. So if my height, okay, over my other height proportions equals my slant height over my slant height, they should come out to equal proportion of 1. Okay? And then I have one more slide and then we're just gonna practice problems in class. Okay, so let's look at this one. Determine whether the pair of solids is similar, congruent, or neither. Okay. So, how can I decide if it's similar, congruent, or neither? What do I need to do? Okay, let's set up some proportions. Let's go with the radius and the height, okay? Let's start with that. What are my radius? It would be what? 6 over 6 equals, and then my height is what?
15 over 16.
Then 15 over 16. We'll just go from this side to this side so we don't get confused. So 15 over 16, right? Does that come out to be equal when we cross multiply? No, because this one's 15, that's 16, okay? So no, and these were the same. So is that similar, congruent, or neither? Neither, because they're not equal, and they're not congruent because they're not the same proportions. Because 6 over 6 reduces down to 1, but 15 over 16 does not reduce down to 1. Okay, so in this case, they're neither. Okay. If two figures are similar with a scale factor of x to y, then their surface areas have the ratio of x squared to y squared. So if they are similar, okay, and I have something, if I have two cylinders that are similar, okay, with a ratio of 2 to 3, okay? I want to know what the ratio of their, what is the ratio of their areas and volumes. How would I set that up? How would I do area?
You just cube it?
Okay, how would I do area?
Oh,
Square what?
no, that's what I meant. I meant squared.
Square what?
So 2 to 3.
Yep, so 2 squared to 3 squared, which means I get a 4 to 9 ratio. How about volume? So 2 cubed to 3 cubed, which means I get an 8 to 27. Is that correct? Yes. So these are the ratios of those. That's what you're doing on that type of problem. Does that make sense? So if they're similar, then I can also work this backwards. So if they say, if they would have said the ratio of their volumes is 2 cubed to 3 cubed, or 8 to 27. Okay, let's say they say it's 8 to 27. What is the ratio of the side lengths? What do you have to do to these to get them back down to 2 to 3? So they said the volume ratio is 8 to 27. Take the what? Not the square. We didn't square this. We did what to it? So I'm going to take the cube root of 8, and I'm going to take the cube root of 27. You might have to work it backwards. So if they give you the volume and ask for the side ratio, you take the cube root of it. If they gave you the area and asked for the side ratio, you would take the, okay, if they give you the area and ask for the volume, you still have to take the square to get it back down to the original and then cube it. Don't think you can just divide it by 2 or just cube that answer, because that won't work, okay? You have to always take it back down to the side length proportions before you can cube or square, okay? So if they work it backwards, it's not hard. Just use your calculator and take the cube root of something, or take the square root of something, okay? All of this stuff that we're doing today is basically cubing, squaring, setting up proportions, setting them equal to each other, cross multiplying, and solving. That's everything you're doing in this homework. I'm going to give you homework in just a second. Okay? That is what we are working on today.
Like,
I will
subscribe,
ask
tweet me at Daybreak Dobert. Anything else to add, Maria? No, anything else to add, Suzanne? Suzanne?